So, you've built an AI model. You've gathered the data, prepared it meticulously, selected your algorithms, tuned your parameters, and evaluated performance. The model is learning well. The numbers look good. You might feel ready to celebrate. But here's the truth: the real journey is just beginning. Because in the world of AI, building the model is only half the battle. The other half? Making it work in production, day after day, decision after decision, in the messy, unpredictable conditions of the real world. Let's talk about what happens after the training phase. That phase, as you know, is where the model learns. It crunches through labeled data, adjusts weights, and finds patterns. It happens offline, often on high-powered machines. But once trained, the model needs to be put to use, into what we call the inference phase. That's where the model begins making predictions, in real time or in batches, for users, systems, or decisions that matter. This transition is delicate. You have to export your model, maybe as a .pkl, ONNX, H5, or TensorFlow's saved model format. Then, you wrap it in an API, using FastAPI, Flask, or gRPC, so that your applications can talk to it. And here's a crucial point: the environment where you serve the model must mirror the one where you trained it. If your libraries, versions, or dependencies don't match, unexpected bugs can emerge. Latency, memory usage, throughput, all of these need to be optimized for a smooth, real-time experience. But deploying a model isn't just about spinning up an API. It's about operationalizing AI, embedding it into real business workflows. Think about this like you would a product launch. You need C/CD pipelines for machine learning. This is the heart of MLOps. These pipelines automate testing, deployment, even rollback if things go sideways. You'll also want to containerize your model using Docker or Podman, ensuring it runs the same way on any machine. Then, you serve the model using frameworks like TensorFlow Serving, Torch Serve, or Triton. And once it's live, that's when the monitoring begins. You keep an eye on latency. You log predictions for audits. You set up alerts if performance drops. This is your AI product, running in the wild. Now, not every deployment happens in the cloud. Some models, especially those used in finance, healthcare, or defense, need to stay on-premise. Maybe it's due to privacy laws like GDPR or AIPM. Maybe it's about ultra-low latency, like in high-frequency trading. Or maybe it's just a regulatory requirement. In those cases, we build Kubernetes clusters, enable GPU acceleration with tools like CUDA or TensorRT, and wrap the model in secure APIs with tight access controls. But for many others, the cloud is the way to go. It offers elasticity. It scales with demand. You only pay for what you use. Oz has SageMaker. Google Cloud offers Vertex AI. Azure provides Azure ML. These platforms don't just host your models, they give you pipelines, notebooks, monitoring, drift detection, and even AutoML tools. But don't forget, cloud choices come with trade-offs. You need to consider regional data laws, latency, and of course, cost. Sometimes we use pre-built cloud services for tasks like translation, transcription, or sentiment analysis. Other times, we bring our own models and use the cloud's power to train and serve them. If you're clever, you can even design hybrid systems, training on-prem, deploying in the cloud, or pushing models to the edge using federated learning. But here's something we must never forget: data is still flowing, even in production. And how we manage that data determines how long our model stays relevant. We need streaming or batch ingestion pipelines. We mirror training time preprocessing in production using tools like Feast or Tecton, which act as feature stores, ensuring our models always see data in the format they expect. We monitor for data drift, when the incoming data starts to look different from what the model was trained on. We watch for output anomalies, for quality drops, and for sudden spikes that signal a deeper issue. And what about the model itself? It evolves. It changes. And so we track everything, using MLflow, DVC, weights and biases, or Neptune. We version our models, our code, our feature engineering logic, even our datasets. When it's time to update, we don't just swap the model out. We test in parallel, with A/B tests, canary deployments, or shadow models that run silently alongside the current version. We measure deltas. We look at performance metrics. We document everything. This is how mature AI systems run, not just as models, but as living digital assets, monitored, versioned, retrained, and improved continuously. So yes, training the model is exciting. But deployment, real deployment, is where the magic actually happens. It's where your algorithm meets the real world, and your innovation becomes impact. Are you ready to make that transition? Because now, you're not just a model builder, you're an AI operator. And this is where the value begins.